So in this particular lecture, we will be studying a very interesting theorem in the concept of limits, which is given as squeeze theorem, or it is also known as sandwich theorem. Sandwich theorem. So the theorem is very easy. What does the theorem say? Ki over an interval, say AB, over an interval AB, if there exist three functions such that, okay, let us name the three functions f, g and h, such that fx is less than equal to gx is less than equal to hx. Okay, and if limit x tends to c fx equal to limit x tends to c hx, x tends to c hx equal to L, wait a minute, is equal to L, then limit x tends to c gx will also be equal to L. So this is the theorem. Okay, if gx lies between fx and hx in a certain interval, okay, then and if we know that the limit x tends to c fx equal to limit x tends to c hx is equals to L, then the limit x tends to c gx will also be equal to L. Let us understand this theorem graphically and then we are done. So suppose we have this particular Cartesian plane and let us draw the functions. So let this be one function, say this is y is equals to, okay, wait a minute, okay, so this is one function, say this is y is equals to hx. Okay, let me change the color. Let me say कि then I have a function say like this, and let this be y is equals to fx, and let I have the last function, say this is like this, and this is y is equals to gx. Okay, now we consider the interval, this to be x equals to a, and say this to be x equals to b. So we can basically see कि between these two intervals the condition fx less than equal to gx less than equals to hx is carefully followed. And see, if I consider this point as x equals to c, then we can easily find that the limit x tends to c hx is equal to the limit x tends to c yx, which basically implies that the limit x tends to c y equals to gx is also will also be the same. That is the concept behind the squeeze theorem, and thus we are done. In the next lecture we will be talking about the delta epsilon representation of limits.